Hello everyone, I'm Maheep Singh and this is my first presentation for Task 3 on the topic Creating Smooth Applications with Block State Management and Architecture. Now, I'll start by giving you a basic overview on the topic through the slides and then we will move on to a demo through a small application I created to help demonstrate how we can use Block. Now, the first question we must answer is what is state management? The Flutter docs state that the state of a Flutter app refers to all the objects it uses to display its UI or man system resources. State management is how we organize our app to most effectively access these objects and share them between different widgets. Now, let's first understand what exactly state is. State refers to data which can change during the life cycle of the widget and affects how the widget is displayed. I'll give you a few simple examples. One is in a basic counter app. The count, which changes as we click a button, is its state. A switch which toggles between on and off, it being on or it being off, is its state. Now, state management refers to how we handle the change in this data to update the user interface efficiently. Now, why is it important? To prevent unnecessary re-renders. Now, imagine a simple counter app. When you click the button, set state is called and the entire scaffold is rebuilt with a new state, showing the updated count. Now, this is inefficient and slows the app down. We only need to update the counter, so rebuilding the whole widget is rather inefficient. We can only update the counter using state management. Now, separating business logic and UI logic. This is done through block architecture, and this makes the code more organized and developer friendly, and also makes debugging easier. It also makes sharing the state across screens, such as say whether a person is authenticated user, much easier. Now, block state management provides two ways of state management. One is a qubit. Qubit is easier to use and simpler in syntax and requires a lower amount of code. It's more suitable for smaller code bases which have fewer developers working on them. Block, on the other hand, are event driven, which makes them traceable, makes them easier to maintain. They have a bit more, they are a bit more syntax heavy, so they are more suitable for larger projects, in which the need for writing developer friendly code exceeds the use of simpler, more syntax friendly code. Uh, right. So I'll explain block exactly through the demo, which we'll move on to. Before that, I'll give you a short uh, explanation about block architecture. I have given an image which represents the structure tree of an application built in block. It basically divides the entire application into three parts: the presentation, the logic, and the data. The presentation is the UI which you see, which the user sees. The logic refers to what happens behind the screens. The logic which makes the app run. When you click on a button, the counter should update. This sort of logic is all stored in the logic portion. Then we come to the data directory. Data stores all the code which interacts with external APIs, the database, anything which is external to the application when you are sending out or bringing in data. All of that is stored in the data repository. Now I'll talk when you're writing code through block, you mainly use a provider and a builder. Now, what is a provider and what is a builder? A provider will create and provide access to a block to the widgets which to its children in the widget tree. The provider handles the creation as well as disposal of the block. This will become more clear when I move on to the demo. The builder listens to the block state and rebuilds the user interface when state change occurs. Uh, right, now builder, listener, and consumer. Uh, Builder rebuilds UI based on the state, and listener executes callbacks or side effects. I'll explain this in more detail when we move on to the code. Right. Let's move on to the code. For the code, the first thing we need to understand is what state is, what an event is, and how these two interact with the block. So I'll explain these things to you with the help of an analogy. Try to imagine a river. This river represents a data stream which is flowing through your application. Now imagine logs of wood flowing through this stream. Now these logs are events in the application. On the edge of the stream, imagine a boy who is building his house. Every time a log reaches to him, he carves it and builds his house. In this analogy, the boy is the block, and the house is the widget that is being built through by the block. Uh, every time he receives a new uh, event in the form of a log, which causes it to change its state. Now let's go step by step in building a block application. I have written these steps in the main.tar. The first step, of course, is to add the dependencies. Go to pubspec.yaml and write flutter block. Add the flutter block dependencies and run flutter pub get so that the package is accessible to you. Uh, Now to explain now to write an application which uses block, first we start with writing the logic. First we start with making a block and writing the logic. Now for that I like to go from the state, then move to the event, and then finally write the code for the block. Uh, right, starting with the state. Here we have a simple counter application. So for a simple counter application, what will be the state? The state will be the count that it is showing. So here we have a class counter state, and it contains one property which is count. And then we initialize a constructor which allows us to initialize the state with a count. Then events are is anything that would cause you to change the state, right? So in a simple counter app, what could cause a state change? We could press the plus button, which would lead to one being added to our state, and we could press the minus button, which could lead to one being removed from our state. So we have two events which extend this class of counter event. The first one being add one, and the second one being removed one. Now, why is this class counter event sealed? It is sealed so that it restricts inheritance. Now, what does this mean? This means that this class can only be inherited from in the file that it is created in. Why is this important? It is important because it helps us to avoid creating unintended event classes and helps us being type safe. Now, imagine you are using switch case statements to handle all possible events somewhere in the code of your application. Now, here that will force you to handle all the cases if you're using a seed class. Moving on to writing the block. Now, let's look at the code. Counter block extends block counter event and counter state. So the block uh, has access to these events, and it changes its state when one of the some of the events any of the counter events occurs. Now we define how the block is to behave when one or the other of the events occur. Now first we write counter block super counter state 0. What is this code representing? This code represents the initial state of the block when no event has occurred. In a counter app, we would want the initial state to be 0. So we initialize a state with the 0 count. Then we define the behavior of the block when any of the events occurs. In case of the add one event, it should emit a new state which is the current state plus 1. And in case of the remove one event, it should emit a new state which is the current state with one minus being reduced from it. Right, so now we'll change up the code so that we can actually see this block in action. For that, first we need to add a provider. You might remember that we talked about a provider in the slides. Now what is a provider? Right, so a provider is something which provides access to a block to all the children beneath it in the widget tree. Now hence we need a provider if we want to utilize a particular block. Now we could initialize a provider here inside the counter screen class, which is this screen being displayed here. Why we won't do that? is because if we do so, every time we go to another screen, the counter screen widget is lost, and hence so is the counter block. So when we move back to the counter screen, our state would be lost and the count would be reset, which we do not want. So we'll make it so that the block is provided by its parent widget, which is here in the main.art. Here we utilize a multi-block provider because we need multiple blocks, one for the counter part of the application and another for demonstrating how we can access APIs through block. So first we'll focus on the counter block. Here it is being provided to all of the children in the widget tree. Uh, so our counter screen gets access to the counter block. We utilize this to create a widget which should display the count of the counter block. So we create a block builder. Now what is a block builder and what is a block listener? First I'll explain the block builder. A block builder is anything which takes a block and utilizes its state to create and update a widget. So, for example, in a counter block, we will want its state to be displayed here in the form of a text widget, and every time we press the buttons, we would want the state to be changed. So, the block builder is utilized to do so. It displays the state of the block, it builds the widget based on the state of the block, and when the counter state is changed, it rebuilds itself. Now, to change the state of the counter block, we need events. So, we want that add one event is called every time we press the plus button, and a remove one event is added to the data stream every time we press the remove one button, the minus button. Now that that is done, I'll explain to you what the listener is. Now, a builder is used to change the UI based on the state. The listener is used to call is used for callbacks or side effects which occur when the state of an application changes. So you must be familiar with callbacks, right? So whenever the state of an application changes, we sometimes want some amount of code, a function, to be executed only and only when the state changes. Here, for example, we have created a listener which will listen to the state of the block, counter block, and every time this counter state changes, it will execute a print statement. Now, why is this different from a normal print statement in the plus button or in the minus button? It is different because this print statement is called only when the state of your application changes. So even if the button is pressed and the state is not be a button is pressed and the state is not being changed, this will not be called, and it is only called when the state of the application changes. It is mainly utilized for side effects. Now, what do I mean by side effects? As a side effect of the state of your application changing, you might want to print something. As a side effect, you might want to show a snack bar, or as a side effect, you might want to change the state of an sorry, you might want to navigate, right? So that's what differentiates a listener from a normal function. Now, what is a block consumer? A block consumer is nothing but a combination of a block listener and a block builder. Many a times in our application, for example, here we need simultaneously a listener and a builder. So a block consumer reduces the syntax and allows you to utilize a listener as well as a builder. Here, to better explain the builder and the listener and to ensure the simplicity of the demo app, I have used them separately instead of using a consumer. Now I'll demonstrate that the app is working as expected. I've hot reloaded the application, hot restarted the application. Uh, you should every time you add a new provider utilize a hot restart instead of a hot reload to ensure that the block is appropriately provided to the widget tree. Now we'll try to press the plus button and we see that the state of the counter changes. Similarly, we'll press the minus button. Now I'll demonstrate to you why we kept the provider in the main.dart instead of the counter screen. If we had kept it in the counter screen, when I return back to the counter would have been reset to 0. But here it is not happening because the parent widget in the main.dart is providing the state. is providing the block. Uh, right. Uh, Now we'll move on to calling APIs through BLoC, because for any actual application, interact with external data through APIs or through or to a database through APIs is extremely important. First, we'll talk about the data repository. Here is all the data directory. Here is stored all the logic for interacting with an external APIs or a database. First, we have a model. This model stores everything uh, about how the thing that we receive from our API looks like. So we should receive a math fact. Now, what does it look like? It should have a type. It should have a boolean, which is whether it was found or not. It should have a number and it should have some text. And we create a constructor so that we can initialize a math fact, and then we create a function which can be utilized to create a math fact from a JSON. Now moving on to the data provider. Here we utilize an API to get some data. Here we are utilizing a simple get call, and I have done some error handling through a try catch block. Now let's move on to the interesting part. Uh, about how the BLoC actually handles this API. The data directory that I showed to you just now was not using blocks in itself, block state management in itself, but it followed the principles of block architecture, which allows us to organize the app. Architecture refers to how you organize the code of an application in a certain way, which makes it more developer friendly and makes it easier to debug the code. Now, for the API block also, we'll move from the state, then to the event, then to the block when we are creating uh, a block-based application. First, we need to think of what kind of states would we want for the API call part of our application. Either it could be that we have fetched a fact and we want to display it, or it could be that the app is currently loading a new fact, or it could be that we have faced an error somewhere along the way. So these are the three possible states. In the fact fetched state, we need to have a fact which can be displayed in the application. Now moving on to the events. What is the event that can change the state of your application? The only event that can occur is that you can get more facts. So for that, we define a single event, the fetch event. Now we'll move on to the code of the block. Now the API block extends the API event and the API state. That is, the block will listen for the API events and have access and update the state. Right. So here we initialize it with a fact fetch state with a null, because the app when we have not fetched any math facts, it is not having an error state, neither is it having a loading state. It has a fact fetched state, but no fact is we do not have a fact currently, so we have a null in case of a fact here. And then we handle the fetch event. In the onFetch function, uh, we first emit a fact loading state. That is, every time we have a fetch event, we try to fetch a new fact. First, we show that the fact is loading in our UI. Then, if we write the code for actually getting the fact. If we do not get the fact as expected, we emit a fact error state. But if we do get the fact as expected, we can emit a fact fetch state with the fact that we have just gotten. In case something goes wrong, which is caught here in a try catch block, we emit the fact error state. Now we'll go to the presentation layer, which shows the actual UI which is presented through the application to your users. And I'll write the code which allows the UI to be updated based on the blocks that we have just written. We'll move on to the API screen. And first of all, again, the provider. We have already written the code for the provider here in the main.dart. Why is it in the main.dart? As I had previously explained, we want the state to be preserved even if we switch between the screens, and hence we put it in the parent widget in the main.dart. Here we provide it with an API block which we create here, which is provided to its children through this context. Now we go on to the API screen. First of all, we need a builder. That is, we want to show the state of the block in the form of a widget. We do that through a builder. So I'll uncomment out this code. We have a builder here which has access, which listens to the API block and has access to the API state. This builder, we have created a switch case statement because we wanted to build different widgets on the basis of the state of the application. In case the state is a fact has been fetched. Now, if the fact is null, which was the case when we initialize uh, our block and no facts have been fetched yet, we want to show try fetching a fact. But if we already have a fact, we show the text of the fact. If we have a fact error state, we want to show that sorry, we are facing some issues. You can try again later. And we handle the loading state by showing the users a circular progress indicator. Now, for any change to occur in the state of the block, we need events to be put into the data stream, right? We need the logs to go into the river so that we can build our house, we can rebuild the house. Now, that is done when we press this text button, the get fact button. So we'll uncomment out this code, which adds the fetch event every time we press the API block. We press the text button. Right, now I'll do a hot restart on our application so that I can show you that the API part is also working as expected. Great, now that the app has been restarted, I'll go to the API portion and we can see here that it is showing try fetching a fact. Now, when we press on the get fact button, first the fact loading state is emitted, which is responsible for showing us this circular progress indicator. And when we get the fact, a fact fetched state is emitted, which is responsible for showing us this fun math fact. Now, I'll demonstrate to you the effects of putting the provider in the main.dart. When we switch between the screens, the state of both the screens is preserved. This shows 2, and this shows the fact that we had just fetched. Now I'll give you a brief overview of the architecture. The architecture here has been divided into 3 main layers: a presentation layer, a logic layer, and a data layer. We have another directory for config, which creates files such as a router or some themes. Now, presentation consists of any code which is essentially user facing. So all the UI code is kept in the presentation directory. All the screens here have been put in the screens directory, and any reusable widgets have been put in a widgets directory. Here we have a navbar which has been put in the widgets directory. In the logic, we define how the app runs, the logic which is behind running the application. So we have both the blocks here in separate directory with the block, the event, and the state files which allow the block to function. Then we have the data directory. This handles our interaction with external APIs or a database. So that is how block state management and architecture works. I hope you enjoyed this presentation. If you want to learn more about BLoC, you can look for the Flutter block documentation. Thank you so much.